So my dear children, now in the earlier lesson parts, we discussed all the things, all the theoretical parts related to our lesson electricity. Now, starting from this chapter onwards, we'll be discussing several questions related to our lesson. Now, first of all, we'll be discussing, like in the earlier lessons, first of all, we'll be discussing about questions related to your textbook. Right. So, first of all, you are given with several MCQ questions, right? So you have to choose the correct answer from these given statements. So first question given, what are the keys or the switches in the circuit that should be closed to light bulb A only? To light up A bulb only, what are the switches that need to be closed? First of all, look at the circuit very well. Now, in order to provide electricity to bulb A, definitely this K3 bulb or K3 switch should be closed like this. We have to close K3 switch. Then, it's electricity coming to here, going to there, coming here. Then once again, here also you can observe a blank. So if you connect this switch also, which is K1, now you can see that to light up A, when crossing K3 and K1, we can light up A bulb, right? So A is now completed, or the circuit on A is now completed. Now A is going to light up. So the two switches that we need to close in here is K3 and K1. So is there any answer regarding K3 and K1? Yes. So our answer would be K1 and K3 only. You don't need to close K2. It's not compulsory. It's because that if you turn on K2, right, the B bulb is going to light up. So it's not that much compulsory. We don't need to light up B. The question is asking only to light up A. So our answer would be K3 and K1. There are four answers about the switches that should be closed to light the bulb C in given diagram. What's the false answer out of those? You have to select the false one. Okay. All the keys. Now we need to light up switch C. It's saying that we have to enclose all the keys, right? Without any trouble, we can say that it is correct. Without even looking at this, we can say that it is correct. You know that if you are going to close all the switches, definitely all the bulbs in the system would definitely light up. So it's correct. Let's go for the second one. K1 and K2 only. So let's close and see. See, K1 and K2 only. So when you enclose K1 and K2, yes, the C bulb is going to light up because you can see that C bulb is now completed with a circuit. So it's going to light up. So this is correct. K1 and K3 only. So I'm going to remove those two lines over there. So let's remove, right? The next one is asking K1 and K3. So we'll enclose K1 and we'll enclose K3. Once again, you can see that current is passing through C without any trouble. See? Without any trouble, the current is passing through C. So once again, you can see that when you are enclosing K1 and K3, the bulb would light up. So let's erase. This is also correct. K1 only. So if you enclose K1 only like this, the C will not light up because in order to complete the current flow through C, either this line should be completed or else that line. Both the lines are now got disconnected. So therefore, we can say that only by closing K1, we can't light up the C bulb. So this is the one which is incorrect. So that one should be our answer. So by closing K1 only, you can't light up the bulb C. Next one. P, Q and R are identical bulbs in the circuit given in the diagram. Which bulb or the bulbs give the brightest illumination? Right? So to give the brightest illumination, entire current should pass from the given bulb. Entire current should pass from the given bulb. Right? So select a bulb which is directly getting connected with the dry cell. So the bulb which is getting directly connected with the dry cells is the P. These two are series connected with P. So after passing electricity through P, it's going to pass to Q and R. So my dear children, P is the one which is going to give the highest brightness. So highest brightness can be observed in P. Where's P? P is in here at the first one. So these are the answers for the first three questions, my dear children. For the first three questions, so we have found out the answers. So let's move on with the next questions then. What is the correct answer about the brightness of the bulbs when circuit is closed? Right. So P and Q, these two lines, this line where P and Q is connected, we'll say that Q line and this line are parallel connected. These two, P and Q, series connected to each other. P is a main switch alone. P is a main bulb which is connected to the dry cell, right? So after passing current through P, it passes to Q and R and S, all the others. First of all, the current is passing to P. Right, now let's see what are the given things. P gives brightest illumination. Q gives the brightest illumination. R and S gives the brightest illumination. Any bulb does not illuminate. So once again, like in the previous case, this P bulb is directly getting connected with the dry cell. So when enclosing, right, when enclosing this switch, the P bulb is the one which is going to give the highest brightness. So the highest brightness can be observed in P. Next one, the equipment that can be used to control the electric current of a circuit to a known value. So this is really simple, my dear children. To a known value, we use rheostat, right? Resistors are the ones which we use to control the current in a circuit. But however, permanent resistors or these fixed value resistors, we can't use fixed value resistors. We can't use these fixed value resistors in a circuit in order to get a desired value, right? So therefore, we can't use a permanent or else a fixed value resistor. Variable resistor is also the same. Like a volume controller, we can't set it to a certain value, exact value. The correct answer is the rheostat. Switches, we can do only turning on and off, that's it. Then the next one given, which one below is a heating effect of electric current? Heating effect of electric current. Light emitting when an electric current is flowing through a LED. Electric current is flowing through an LED, the light which is getting emitted. Heating of a bulb when a current is flowing through a filament bulb. Heat emitting when a candle is burning. Heating of a metal plate when sunlight falls on it. So they are asking about heating effect of electric current. So obviously these things are incorrect because electric current is not given over there. Light emitting is the lighting effect. So our obvious answer would be heating of the bulb when a current is flowing through a filament bulb. This is our answer. So over here, it's a lighting effect, and these two are irrelevant with the question because there's no current being used over last two questions. Several phenomena are given below. Emission of light when electric current flows through a LED, attraction of pins to a copper coil when current is flowing through it, flow of an electric current when sunlight falls on an LDR of a circuit, plating gold on jewelry in electroplating. Which one of the above is not an effect of electric current? Not an effect of electric current. So emission of light when electric current flows through an LED, correct. When electric current is flowing through a LED, you know that light is getting emitted. So it's the lighting effect given out by the electric current. Attraction of pins to a copper coil when current is flowing through it, that is also correct. This is the magnetic effect. Flow of an electric current when sunlight falls on an LDR of a circuit. This is the incorrect one, my dear children, because current is not getting generated when sunlight is going to fall on LDR. That's a solar cell, right? In an LDR, right, we use an LDR in order to control the current in a circuit. We can't generate current by an LDR. So therefore, electric current is not going to flow when sunlight falls on it. Plating gold on jewelries in electroplating, this is also correct. Here we use the chemical effect of electricity. This is also correct. Which one above is not an effect? So the not an effect one should be C. When the electric current flowing through a conductor is reduced, the strength of the magnetic field generated. Now current is reduced. They are asking about the strength of the magnetic field. When electric current is reduced, what happened to the strength of the magnetic field? It increases, it decreases, first decreases and then increases, does not change. So my dear children, you know that when the current is reduced, the strength of the magnetic field also decreases. What are the factors below on which the strength of the magnetic field generated in a current flowing coil depends? So there are three factors that's going to depend the magnetic field generated on a conductor with the effect of the electricity. First one is the length of the conductor or the number of turns in the conductor. Second one, the type of coil present within the conductor or coil. Third one is the magnitude of the current. So my dear children, let's see what is the odd one given here out of those three cases. Amount of electric current flowing, correct. Number of turns of the coil, correct. Type of core in the coil, once again correct. Direction of the current flow, irrelevant at all. So A, B and C should be the answers. The fourth one it is given. A, B and C is the answer. Right then the final question. Which electrical appliance does not use an electromagnet? Now most of the times if you take motors, my dear children, motors are utilizing magnetic effect. Magnets are utilized in motors, right? By placing a magnet, or magnet is really important for a motion. Otherwise, there is no motion at all. Magnetism is really important during the motion of fans, right? A fan is going to work because of the magnetic effect plus the current effect as well. So each and every motor, electric motor, is going to use this magnetic effect. Most of the electric motors are made up with electromagnets. In order to provide the magnetism, electromagnets are being used. So select an answer where there is no motors in rotation. That's the one which does not use electromagnets. So let's see. Electric bell. Even we discussed how to create a simple toy electric bell under the magnetic field or the magnetic effect given out by electric current. So this is absolutely correct. Electric fan, there is a motor, it's rotating, so it is correct. Handrail, there is a motor, it's rotating, it's correct. Immersion heater, not at all. We dip that thing in water and we generate heat energy to boil water in the immersion heater. So it's the incorrect one or the false one. So the appliance which does not use an electromagnet is the immersion heater, right? Immersion heater. Circuits below show the different ways of connecting several bulbs with a cell. Now after finishing out MCQ questions, now we came to the essay type questions given. So circuits below show the different ways of connecting several bulbs with a cell. So here you can observe a parallel connection. Here once again a parallel connection. Over there is a once again a parallel connection. So all A, B, C are parallel connections. And once again in H also you can observe a parallel connection. How can you see that? See? These two terminals connected directly to positive and directly to negative, right? And this terminal with this terminal, see, this one and this one are connected with this bulb, once again with this bulb as well. So all the three bulbs have same terminals. If you follow the lines, very carefully, let's imagine that I'm going to use two colors in here. So one terminal, it's connected with this terminal, and once again this terminal, see, up to here. Okay, so 1, 2, 3, these three terminals are joined together. Then after that, check this one, the other terminals, this one, this from this bulb, these two together at this point, connected to each other. All three are running towards the negative terminal. All three greenish ones are running towards the negative terminal. All three pinkish ones are running towards the positive terminal. So my dear children, H figure is a parallel connection. So others are very simple and very easy to identify. This is parallel, and parallel. So all the, and this one also parallel, right? So A is parallel, B is parallel, C is parallel, F is parallel, then after that H is parallel. All the other things then should be series connected. Yes, those things are series connected. So this is series, and series. Right, what are the circuits here in which the bulbs are connected in series? So G, I, D and E. There are 4 circuits in series connection, right? 4 circuits. Series, series, series and series. DEGI, DEGI. What are the circuits here in which bulbs are connected in parallel? So the parallel connections can be identified in A, B, C, A, B, C, F, H, F and H. So there are 5. 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. A, B, C, A, B, C, F and H. Correct. So these are the parallel connected ones and series connected ones. So I know that you got a sound knowledge to identify what are the parallel connections and what are the series connections. If all the terminals are connected together to run or to connect to a dry cell or to an electric source, then it is a parallel connection. If one is passing through to the other and through that one to the dry cell, if the current is passing from one thing to another, right, then it is a series connection. Right, so let's move on with the other question. In the circuits below, all the cells are identical and all the bulbs are also identical, okay? So here, one cell. So each of the figures, there are 1 cells each. So this is a parallel connection one. So if it is parallel connection, it's going to show a good brightness as the voltage is entirely passing through both the bulbs. So this is a series connection. Electricity is getting divided and traveling. Once again, a series connection and a parallel connection. So in both parallel connections A and B, the entire voltage is passing through the 3 bulbs and in here 2 bulbs. However, in a series connection once current is getting divided, actually not the voltage is getting divided, and due to that division, right, voltage is getting divided, and due to that division, the brightness given out by series connection ones are somewhat lesser than the other. Right, now let's see, out of those given above, in which circuits have the bulbs with maximum brightness. So maximum brightness can be observed in parallel connections as they have the equal amount of potential difference between the 2 terminals. So A and D are parallel connected ones. So our answer should be A and D. In which circuits have the bulbs with minimum brightness? In which circuits, as they are asking about the circuits, right? Minimum brightness as they are asking about the circuits. So we can write like this. I'm going to give you a complete answer. The lowest brightness can be observed in C because there are 3 bulbs. So lowest in C, right? Lowest in C. In B, more than C, as there are only 2 bulbs, but less than AB. So as they are asking about circuits, right? So you have to mention both. So lowest can be observed in C, but in B you can observe more brightness than C, however lesser than AB. So altogether, right, altogether, like if you take to a summary, then both B and C are the ones that has lower brightness. Okay, right, then let's move on with the next question. Out of those given above, which circuit contains dry cells connected in a series manner? In a series manner. So we have to find out the cells which are connected in series manner. In order to connect in a series manner, positives should be connected with negatives to pass electricity, right? Positives should be connected with negatives in series connection. So let's see, here positive, right? And here negative, here once again negative. So positives are joined with negatives, negatives with positives. Opposite terminals are connected to each other means A. A is an answer for a circuit which contains dry cells in a series manner. Then here negative, positive, negative, positive. How to identify the negative and positive terminals? It's real simple, my dear children. Longer terminal is the positive, shorter terminal is the negative. So once again in B also you can observe opposite terminals interconnected each other. So B. Select the circuits in which dry cells are connected in parallel. So parallel connection, plus with plus, minuses with minuses. So plus with plus, minus with minus. All the things are joined here and traveling towards the bulb. So C is a parallel one. Once again in here, this one is positive, this terminal is also positive, this is also positive. So all the positives join together from this line coming towards the bulb. Then this negative, this negative, this negative, all negatives are joined together coming towards the bulb. So D is also the same. D is also the same. Right. So my dear children, these are series and parallel connection in cells. Series connection in cells and parallel connection in cells. Several circuits, electric circuits are given below. All bulbs used are identical and all the electrical cells are also identical. Okay. So let's see whether these things are series or parallel first. This one. So here, this one is the shorter one, this is negative, right? This is the lengthier one, this is positive. Lengthier one once again positive, shorter one negative. So negative with positive, series. Positive with positive, negative with negative, interconnected and coming towards the bulb. So it is a parallel connection. Positive coming towards here with the negative one, and this negative one running towards their positive, and this is negative. So negative, positive, negative, positive, negative, positive, series, right? Series. One to the other through different terminals. Here negative, 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 all three are joined together to pass towards the bulb. Positive, 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 all three joined together to pass towards the bulb. So my dear children, let's see which circuit have the bulbs with maximum brightness. So maximum brightness can be observed when the cells are series connected as the voltage is getting increased. Voltage is getting added up. So for an example, if this one has 2 volts, then 2, 4, 6, entire voltage in here is 6 volts. Through the bulb, 6 volt of electricity is passing. So if it is over there 2, then this one also should be 2. So here the bulb has 4 volts. Here the bulb is having only 2 volts. And here also the same bulb is having only 2 volts. It's because that when cells are parallel connected to each other, right? The voltage is never getting changed, and we discussed that if the cells are parallel connected, we can use those instrument or bulbs for a longer time period, right? So which circuit have the bulbs with maximum brightness? Maximum brightness can be observed in, especially maximum, or the maximum brightness can be observed in C. So they are asking once again about the circuits. So as they are asking about circuits, we'll mention A as well. Okay, circuits. So A is correct, but the brightest can be observed in C. Brightest. Mention as A also. A is also correct, no problem. Which circuits have the bulbs with minimum brightness? So minimum brightness can be observed in B and D. Both B and D, the brightness is same, right? Brightness is same. Write them. Write down the answers for the following questions. You have to write down the answers. What are the components which can be used to control the electric current? To control the electric current, what are the components that can be used? So there are several components. You can write resistors. What are the examples? Fixed resistors. Then variable resistors. Variable resistors. Then light dependent resistor. Light dependent resistors. So resistors can be used. Under that there are special kinds: fixed resistors, variable resistors, and light dependent resistors. Number 2, switches. Switches can also be used to control the current. Control means actually turn on and off the current flow. Switches can also be used, right? Current controlling devices. Right. Explain briefly how the electric current is controlled by a light dependent resistor in a circuit. Right. So how does the light dependent resistor is going to work? It's like this. When light falls onto the resistor, intensity of the light is getting increased. Due to that, resistance is reduced. Upon reduction of resistance, current flow through the circuit is getting increased. In reverse, when dark is falling or when there is less amount of light, the resistance of the LDR is getting increased. This is getting increased, right? Resistance of the LDR is getting increased. So thereby, less amount of electrical charges will flow through the circuit. Therefore, the current flow will reduced. So resistance will increase when dark falls. Resistance will decrease when light falls. Okay, so we'll write it down. When intensity of light is high, when intensity of light is high, resistance of the LDR reduces. So when intensity of light is high, resistance of the LDR reduces. Higher the intensity, lesser the resistance. Therefore, greater current will flow, right? Therefore, greater current will flow. The second point, the opposite of that thing, when intensity of light is low, resistance of the LDR increases. Right? Resistance of LDR increases. Therefore, lesser current will flow. Lesser current will flow. Right. So this is the answer. This is how LDR is going to control the amount of electricity. When intensity of light is high, resistance of the LDR reduces. Therefore, greater current will flow. When intensity of light is low, resistance of LDR increases. Therefore, lesser current will flow. So, once again, when intensity of the light is high, resistance of the LDR reduces, greater current will flow. When intensity of light is low, resistance of the LDR increases, therefore less current will flow. Current and resistance showing opposite relationship, my dear children. Right, then to move on with the next question. What are the points that attention should be paid when using electrical appliances? What are the points that attention should be paid when using electrical appliances? When we are using household electrical appliances, what are the points that we need to take into our consideration? It's saying, what are the points that we should pay when using, my dear children? Using means now we are operating these instruments in our home. Okay. So when operating, what are the things that we need to follow? Precautionary things. So I'll write 3 as there are. So they are not asking about exact value or how much do we need to write. So I'll mention 3 of them. Number 1 is, when using electrical appliances, we should never touch those things with our wet hands. If you have wet hands, first of all, wipe your hands from a clean cloth. Then after, you can use it. Okay, because water is a conductor of electricity. If different substances, salts like things are getting dissolved in water, then that salt is behaving as a conductor, as it has mobile ions. So it's important to dry out our hands before touching these electrical appliances. So not touching or not using with wet hands. not using with wet hands. Then if there are more powerful electrical appliances like heaters, powerful means they draw out heavy amount of electricity. So if there are powerful electric appliances like heaters, right, especially in heating equipments like heaters, then irons, rice cookers, it is a good practice to use a pair of slippers if you are using these things more often, especially with irons, right, electric irons, because if the current drawing out from the circuit is very high, then there is a risk of getting electric shock. So in order to avoid that kind of a condition, we can wear always a pair of slippers. So when using heating equipments like irons, rice cookers that utilize electricity, it's wise to use a pair of slippers, right, to avoid electric shocks. Wearing a pair of slippers wearing a pair of slippers when using iron, rice cookers, hot plates. Etc. So wearing a pair of slippers when using iron, rice cookers, hot plates, etc. Then this is very important, my dear children. If there is lightning and thundering, we should never use these electrical appliances, right? As there is lightning and thundering, we should never use it, because there is a possibility that we might distract with lightning, as these things have conductors, right? So the next one would be not using these when lightning, right? When lightning, we should never use electrical appliances. So these are the things that we need to follow when using household electrical appliances. Not using with wet hands, wearing a pair of slippers when using iron, rice cookers and hot plates, etc. Not using these when lightning. When there is lightning. When there is lightning. Right. That's much better now. Right. Also I'll erase this one and rewrite. It's good for you. And there is not using these when there is lightning. So these are the special things that we need to follow. 3 special key points that we need to follow when we are using household electrical appliances. Right then. What are the effects of electric current? So we studied 4 effects of electric current, my dear children. Magnetic effect, lighting effect, heating effect, chemical effect, right? Magnetic effect, magnetic effect, heating effect, magnetic effect, heating effect, lighting effect, right? Lighting effect, we'll use ing. So lighting effect. Then finally, chemical effect. So these are the 4 types of effects given out by the electric current: magnetic effect, heating effect, lighting effect, chemical effect. Right. State the energy transformation that occurs in each effect you mentioned. Energy transformation. So we discussed that thing when we are discussing about the theoretical parts. Most of the times when operating each and every electrical appliance, electricity is getting converted into different types of energy. Now in these each of effects also you can observe the same thing, right? So here the electricity which is provided is getting converted into different other forms of energy. So we'll write down one by one each. So magnetic effect. So in magnetic effect, my dear children, what happens is electricity turning into magnetism, right? Electricity to magnetism. Magnetism is a type of a energy. So electricity is getting converted to magnetism. Next one, number 2. Lighting effect. So in lighting effect, electricity getting converted to light. Electricity is getting converted to light. Then number 3, third one, in number 3, third one, heating effect. Heating effect. In heating effect, electricity to heat energy, right? Electricity to heat energy in heating effect. Then finally, number 4, chemical effect. In chemical effect, my dear children, electricity is converted to chemical energy. Right? Chemical energy. So these are the 4 effects and their energy conversion. In magnetic effect, electricity is getting converted to magnetism or magnetic field. In lighting effect, electricity is getting converted to light energy. In heating effect, electricity is getting converted to heat energy. In chemical effect, electricity is getting converted into chemical energy. So these are the four main types of effects and their energy conversions. Mention one electrical appliance found in daily usage with using each effect of electric current mentioned above. Right. So according to the earlier cases, right, you have to mention electrical appliance found in daily usage. Okay, electrical appliance that we used in daily usage that show given below above changes. Right? Okay, so we'll write down number 1. Light effect. Light emitting diode, or in short form we can write LEDs. Number 2, heating effect. For heating effect, heaters. Then number 3, magnetic effect. Magnetic effect, electric bells. Magnetic effect, electric bells. Then finally, fourth one, chemical effect. So my dear children, chemical effect is the final one. Okay, so when you take chemical effect, especially, right, in electroplating and electrolysis we can observe the chemical effect. I told you that, right? Especially in electroplating and electrolysis we use chemical effect. So my dear children, specialty here is that there are no certain types of household electrical appliances that carries chemical effect of electric current. But however, in electroplating and electrolysis, we use these incident, or we utilize the chemical effect of electric current. But there are no certain types of electrical appliances. So therefore, we'll write down the use of one thing. Okay, so we'll write down the use in plating gold on medals. Right, in plating gold on medals. Right, so these are the instances, or these are the special instruments, electrical appliances that we utilize in our day-to-day life that gives light effect, heat effect, magnetic effect and chemical effect. For the chemical effect, I told you that there are no any certain type of a appliance, but however there is a use like plating gold on medals. Okay, so LEDs giving out the light effect, heating effect, heaters, magnetic effect, electric bells, and in chemical effect we wrote a use like plating gold on metals. Right, then using diagrams, describe briefly the way of making simple electromagnet. Okay, the way of making a simple electromagnet. First of all, we'll be needing these materials. Insulated copper wire. Insulated copper wire materials. Then iron nail, as it is saying simple electromagnet, and iron nail would be perfect. Iron nail. Then switch and tri-cells. Then the method. So I'll draw and show the method, children. This is my iron nail. What I'm going to do is I'm going to now wrap the coil and connect it to dry cells like this. Through a switch. So this is the coil, iron nail, coil, dry cells, switch, right? And if you want, I'll mention that one also, connecting wires. So you'll be needing these materials first: insulated copper wire, iron nail, right? A switch, then several dry cells and some connecting wires. Then this is the coil which is wrapped around the iron nail. Then we have to clean the two ends of the coil and fix it. Like we have to fix it to the circuit as per to the diagram. Then what do you have to do? Turn on the switch, and if you want you can place this setup near some drawing pins and see what's going to happen, right? So they're asking about only the method. I have drawn the method. Then I'm going to write down what are the steps here. So the steps are really simple. Wrap on the nail, wrap the wire on the nail as per to the diagram. Wrap the wire on the nail as per to the diagram. Then clean the two ends well. and connect with the dry cells clean the two ends well and connect with the dry cells according to the figure. Turn on/off the switch when needed. So it's really simple, my dear children, how to make a simple electromagnet from these materials. See, so you'll be needing these materials: insulated copper wire, iron nail, a switch, several dry cells, connecting wires. So first of all, you have to make a coil, means that by wrapping the wire around the iron nail, we have to make a coil. Then after that, the dry cells, then the switch. We have to connect the two ends of the coil with the dry cells according to the given figure through the switch, right? Then after, if you are having several drawing pins or any other pins, you can turn on the switch and see what's going to happen. So here it is given: wrap the wire on the nail as per to the diagram, clean the two ends well and connect with the dry cells according to the figure, turn on or off the switch when needed. So this is our simple electromagnet. What are the factors on which the strength of an electromagnet depends? What are the factors? So there are three key factors which the strength of an electromagnet depends on. First one, length of the conductor, number of turns in the conductor. Number two, the type of the core which is present within the coil or the conductor. Number three, third one, the magnitude of the current which is flowing through the conductor or the coil. So we can write down the answers. Number one, magnitude of the current, right? Magnitude of the current. Number two, type of the core in coil. Type of the core in coil. Number three, number of turns in the coil. Length of the coil. Or the conductor. Right, so these are the three factors. Number one, magnitude of the current. Magnitude of the current passing through the coil or the conductor. Number two, type of the core in coil. Type of the core. Material of the core, right? Number three, number of turns in the coil. Here the coil means the conductor which it is being wrapped. Actually, number of turns means here we are changing the length of the coil. So these are the three main key factors that is going to affect the magnetic effect given out by electric current. What are the effects of electric current used in the LED? and in the filament bulb. So in the filament bulb, my dear children, in a filament bulb, I told you that the main effect or the main energy given out is the heat energy. Upon getting heat energy, it's getting heated up to extreme temperature to emit light energy. So light energy is not the main type of energy conversion which is going to happen inside a filament bulb, but it is the heat energy. So in a filament bulb, main energy conversion or the main effect given is heat effect. Heating effect, right? Heating effect. Then in LED, directly instead of heating, it's getting converted to light energy. So light energy is the, or light effect is the main effect which is given out by LEDs. So LED lighting effect. Right, lighting effect. So in the filament bulb, the heating effect is the main effect given out, and in LED, lighting effect is the main effect which is given out. Discuss the importance of using an LED instead of a filament bulb. So my dear children, we discussed several uses when using LED over a filament bulb, right? I think you could remember. Now let's memorize once again what are those uses, right? What are those important facts? First thing is that in an LED, less energy is getting consumed. It's because that main energy given out is the light. But however, in a filament bulb, main energy given out is the heat. Secondary energy is the light. So less energy is getting consumed by LED. LEDs are going to consume less amount of energy, right? And we discussed that if you get the same light energy given out by 20 watt, 15 to 20 watt LED, then you have to at least put 100 watt value of filament bulb, right? 100 watt of a filament bulb is equal to watt value of a LED bulb, which is between like 15 to 20. Same intensity of light is given out by both the instances. However, filament bulb is using more amount of electrical energy as it has high amount of power, right? That's the first one. Then in the second instance, or as the second advantage, we discussed that lifetime of LED is very higher than normal filament bulbs. If you take an LED, the lifetime or the number of hours that we can work with an LED is about 20,000 hours. However, if you take a filament bulb, it's around 1,000 to 5,000 hours in maximum. That's the maximum value, right? Sometimes even in different kinds of filament bulbs, this lifetime is even less than that, right? However, if you compare lifetime of a filament bulb with a lifetime of a LED bulb, LED bulb is like 10 times, more than 10 times it has the lifetime. So that's the second main important use. And the other thing is that as these things are consuming very less amount of electricity, it is cost effective. In long term, large amount of money can be saved if you are going to use LED bulbs. Okay, initial cost is somewhat greater, but however, it's a good investment for the future. In long run, you will be getting benefits if you use LEDs, right? So these are the key points or key factors when using LED instead of filament bulbs. So we can write like this. Number one, less less electrical energy is used, right? Less electrical energy is used. Number 2, more lifetime. About 20,000 hours. About 20,000 hours. Then number 3, cost effective. In long run, right? Cost effective in long run. Long run mean in future, right? In future, your money is getting saved. Not in recent times. When I'm going to buy a filament bulb, I told you that it's like 5 times. When you're going to buy an LED bulb in normal commercial market, just now, it's about 5 times the price of a filament bulb, right? LED is somewhat expensive, but however, right? But however, in the long run, your money is being saved by the electrical energy. Right, my dear children. So we have written down all the answers for the questions given in your textbook. Now it's time to do some extra activities, extra exercises. So in the next chapter, we'll discuss several extra questions related to electricity lesson.